Okay, so does anyone have any specific? Yes.
Can we go over the questions that were kind of on the quiz, the type of questions?
Did you look at the quiz solution?
For quiz 2? No. Wasn't everyone having different numbers?
Yeah, but the general solution's on there, right?
Okay.
You have the solutions for the 3 columns without the graph.
Yeah.
Yeah, we did that.
3 with the graphs, yeah.
Okay.
Yeah. Okay, so does anyone have any specific problems on, or questions, I should say?
Yeah.
V versus T graphs.
Uh-huh. Okay, so,
Can you do the one with the Usain Bolt in the homework?
That one.
all right, let me do V versus T. So the homework solutions and the quiz solutions are posted, right? So I'd rather do something that I didn't already do to make it more effective use at this time. So someone had a question for V versus T graphs. Let me do that first. I'm just thinking of a question with the V versus T graph. All right, so suppose, okay. Let's just do this. Okay, so suppose you're given the following V versus T graph. Okay, so it looks like this, right? I'll just make this up. So this is V, this is T, and so the graph looks like this, right? So it's just the graph. All right, let's make it look a little bit different than you've seen before, just so it's a little bit, maybe makes you think a little bit. All right, so suppose it looks like this, right? It's not that complicated, but so suppose this time here, actually sorry, I'm going to add something to the end of it, right? So it's not going to change this part, but I want to add something to the very end of it. So it's still a straight line there. You can just keep the line. I'm just going to add something at the end. All right, so it looks like, oops, it's not the best, whoops, sorry. It's not the best thing, graph, but, okay, so it looks like this. And suppose this is, I'm just making these numbers up. So I don't know how they work out, but it'll be fine. I don't know if they'll work out to be nice numbers or not nice numbers, but it doesn't matter. Okay, so suppose this time here is, let's say 2 seconds. This is 4 seconds. And this is 5 seconds. And then suppose that this velocity, sorry, I'm trying to just line it up. Okay, so that velocity is, say, 10 meters per second. Obviously, it's in the positive x direction because it's above the axis. Okay, so it took me a little while to draw that. But, okay, so you can ask all sorts of things from this graph. You can ask, let's just ask this first. Okay, so you can ask, what is the total displacement from 0 seconds until it stops?
You have to detest the them all at the same time, same room, right?
Yeah,
Okay.
yeah.
Wouldn't it be zero the displacement, cause you kind of ended zero?
No, this is, so what's going on here in this graph? First of all, if you just look at this graph.
Oh, wait, negative 10,
Okay, so what's happening here?
increasing
What's increasing? V?
velocity.
So what is it, what are you doing? You're going faster in the positive x direction until you hit 10 meters per second, correct? And then what happens from 2 to 4 seconds? You go at a constant velocity of 10 meters per second with acceleration of 0. And then what happens from 4 seconds to 5 seconds? You're slowing down until you stop. So you're always going to the right. You're never going to the left. So therefore, your displacement is not 0, right? Okay. So try to figure this out. Like, try to actually calculate it, and I'll tell you if you're right or not, because you need to know how to do this for tomorrow, right? Okay.
You just want us to tell you? Or?
Yeah, if you have an answer.
Displacement is 35 newtons.
Yes. Technically in the positive x direction, though, right? Because if you ask for displacement, it's direction 2. So what you need to do to figure this out is just find the area, right? Because displacement is the area under the graph. So this thing just happens to be 3 different shapes, right? So from 0 to 2 seconds, it's a triangle, right? With the base of 2 and a height of 10. And then from 2 to 4 seconds, it's a rectangle, also with a base of 2, because it's 4 minus 2 seconds, right? And a height of 10. And then the last thing is another triangle here with a height of 10. They all have the same height. What's the base of the last triangle? 1 second, right? So you just got to add all those up, and that'll give you the total displacement. So it would be the, for the whole thing, it would be the area of the first triangle, which is 1/2 the base, well, 1/2 the height, I should say, times the base, which is 2 seconds. That's 10 meters, right? For the first, from 0 to 2 seconds, it goes 10 meters. That's just what that equals. And then for 2 to 4 seconds, it's a rectangle. So the height of the area of a rectangle, I should say, is just the length times the width, or the height times the base. So it's 10 meters per second times 2, right? Because the width is 4 to 2, right? 2 to 4, so it's 2 seconds. So from 2 to 4 seconds, it goes 20 meters, right? So from 0 to 4, it goes 20 meters plus 10 meters, right? 30 meters. And then the last thing is the triangle, the last triangle, the smallest one. So it's 1/2 the height, which is 10, times the base. What's the base of this one? Again, 1 second, right? 4 to 5 is 1. So just that by itself is 1/2 of 10, which is 5. So this is 10. The orange one is 10. This is 20, and the last one is 5. So it's 10 plus 20 plus 5 gives you what? 35, right? Okay, so plus. So basically, it's in the positive x direction. Okay, so does that make sense? Mm-hmm. Okay. So let's ask something else related to displacement, and then we'll go on to acceleration, because the two main things for v versus t is displacement and acceleration. But let's just ask one more question related to displacement. So b is what is the average velocity? Oh, the other thing I didn't point out, but it should be obvious. I'll go back in a second. From 0 seconds to 6 seconds. Okay, sorry, 0 to 4. 0 to 4 is what I meant to say. 0 to 4. I don't know where I get 6 from. But You should know that obviously when it gets to the horizontal axis, it stops, right? That's where it stops. You have to know that too. Okay. So the question is, what's the average velocity from 0 to 4 seconds? Right? That's the question. Okay, so try to figure that out. I'll copy the graph down here so you don't have to scroll back and, or you don't have to, I don't have to go back and forth here. Answer for the average velocity from 0 to 4 seconds?
It's 2.5 meters per second.
2.5?
Yeah. Isn't that 10 over 4?
From 0 to 4.
Oh, you said 0 to 4.
Yeah. It's okay.
Never mind.
It's okay. What was it? Yeah, 7.5, right? Also in the positive x direction. So what you need to do is find the delta x from 0 to 4 first, right? So we know from 0 to 5, we know what that is because that's what we figured out in the last part. But from 0 to 4, it's the first two parts, right? It's the area of the first triangle, which is this, as I went over in part A, plus the area of the rectangle, which is this, right? Which is the same thing as part A. So this works out to be, I don't know why it doesn't go back to normal, but this is plus 30. So from 0 to 4 seconds, you go 30 meters in the positive x direction. And then there's only one equation for average velocity. So it's displacement over time, of course. These could be different displacements in different times. I mean, this could be the displacement for the entire thing, the displacement for the first 2 seconds, the displacement for the first 4 seconds, from 2 to 4 seconds. But this is from 0 to 4 seconds. So you need a displacement from 0 to 4 seconds, which is why we found that. And then you divide it by the time it takes to travel 30 meters, which is 4 seconds, right?
Mm-hmm.
So it's, yeah, that's all it is. So it's plus, once again, also in the positive x direction, right? The displacement and the average velocity are the same sign. So the average velocity is 7.5 meters in the positive x direction. Okay, so the other thing, of course, you can get from v versus t graphs, besides displacements and things related to displacements, is the acceleration. So the question is, what's the acceleration from 0 to 2 seconds? And I'll copy this graph down again, so you can see it. But this is pretty straightforward, I think. Okay, so it's not too hard to figure out. Does anyone have an answer first before I tell you how to do it?
2.5 plus 5.
Yeah, it's 5, plus 5. Okay, so how would you find acceleration from a v versus t graph, first of all? It's the slope. In this case, from 0 to, all right. So from 0 to 2 seconds, right? So you got to find the slope of this line. That's all you need to do. So, A is the slope for v versus t graph. So it's just the rise, so what's the rise for this case? 10 plus 10, because you go up 10. And then what's the run from 0 to 2?
Plus 5.
Almost. I mean, just 2, right? 2 seconds is the run?
Yes.
Yeah. Okay, so it's plus 5 meters per second squared. Right. This is also in the positive x direction. All right, so it's just the slope. I'm not going to ask, but just quickly, what would the acceleration be from 2 to 4 seconds? So if I ask for the acceleration from 2 to 4?
0.
0, right? Because it's constant velocity. The slope is 0. You can just see it, right? You don't have to calculate it. All right, so I'm going to ask one more part here related to the acceleration from 4 to 5 seconds. So the question is, what's the magnitude of the acceleration from 4 to 5 seconds? Okay, so I'll copy this here again so you can see it. But, okay, so that's the question, right? What's the magnitude of the acceleration from 4 to 5 seconds? So what's the answer? Yeah, just 10 meters per second squared, right? That's the answer. So it's the same thing that we did in this one, right? It's the slope, obviously. But if we're doing it carefully here, right? What's the quote rise from 4 to 5 seconds?
Probably 10.
It's actually negative 10, right? I'm just showing you something, right? It's actually negative because you go down, right? You go down 10, not up 10. So then you divide, all right, so what's the run from 4 to 5? 1. So you get negative 10 meters per second squared, which would kind of be the answer if I was just asking for the acceleration itself. It's 10 meters per second squared in the negative x direction. Right? Everyone sees that it slopes down. But if I'm asking for the magnitude, which is something you have to know, and know what I'm asking in the question, then the magnitude is always just how much it is, right? You don't care for the direction or the sign, right? So it's just that, right? So it's just 10 meters per second squared. It's not negative 10. It's 10. And I don't care about the direction, right? It's just how much it is. So the actual acceleration is negative 10, if that's what I asked for. But the magnitude is 10, right? Just 10. All right, so does that make sense? All right, what other questions? Yeah.
Will we have any questions on position versus time?
Just conceptual things, like how you find, like, so if you give an x versus t, you can approximate the instantaneous velocity. Remember, it's just a tangent line. So you should be able to know if it's going tangent lines positive, 0, or negative. And then just figuring out, like, the general idea with average velocity. So the average velocity is just you connect 2 points with a straight line. Mostly conceptual questions from that stuff, not that many calculations, right? If there is a calculation, it's just all conceptual. Okay, what other questions? There's not much physics on here. And so there's distance, displacement, right? Average velocity, average speed, that stuff. And then there's the constant acceleration stuff. So, and proportions, I guess, is the other thing that people have problems with. What other questions? Yeah.
Can we do one like similar to the quiz questions, but like not as easy as like the first 3? Like if the car's going in one
Oh, the
direction.
distance ones?
Yeah.
Okay. Okay, so I showed you the Michael Phelps race, right? Where
Yeah.
the race was 100 meters. So 50 meters back, 50 meters one way, right? So you have a race, swim race, right? They go 50 meters one way, hit the wall, go back, 50 meters, go back. Okay, so you can have 200-meter races, right? So they have to go back and forth 4 times. Okay, so in a 200-meter swim, I don't know what they even call it, race, whatever, it doesn't matter. You understand what I'm saying?
Swimming.
Is it, but the meet is the whole thing, right? So the individual race is, I guess it's the race, right? Anyhow, it doesn't matter. So a swimmer travels back and forth 50 meters 4 times. Everyone understands what I'm saying, right? So they start here, right? Over here is 50 meters, right? So this is 50 meters. And they go back, you know, like this, right? Until they get back to where they start, right? Everyone understands what I'm saying? Okay, okay. So the question is, this. If a swimmer's average speed is 2.2 meters per second, and the swimmer swims for 80 seconds, answer the following. Okay, so the question is, okay, so you have to do this to figure out the rest of it. So this is pretty straightforward, but still, I'll ask it. Hopefully everyone gets this right. What distance does the swimmer swim? I don't know. It's probably a better way to say that. What distance does he travel, right? That's probably the better way to say that. All right, so this is a kind of an easy question, but try to figure it out, right? Gets it. Just to be clear, this is in 80 seconds, right? Because you could say, well, do you mean, in 80 seconds or 30 seconds or whatever? With the time given, how far does he go? Okay, so does anyone have an answer to that?
176 maybe.
176, yeah. Because there's only one equation for average speed, right? So average speed, as you should know, but it's on the equation sheet, is distance divided by time. So we've seen this quite a few times in the homework and in the examples and in the quiz. So the average speed is just, distance is average speed times time. So if you know your average speed, which in this case is 2.2 meters per second, you multiply that by 80 seconds, and you get 176 meters. So he's not quite finished with the race, because the race is 200 meters, correct? He's not quite back to the point he started from. So the next question is, and you kind of have to, all right, so I guess I have to draw a little sketch to make it clear exactly what I'm asking. But the next part is, what is his displacement after 80 seconds from the start of the race? So what I mean by that is, let me just draw a little sketch. It's a pretty straightforward sketch. So he starts here, right, at that X. All right, and then, he goes, the wall's over here, this is 50 meters here. So he starts over here. It's what I described before. He starts over here, goes 50 meters this way, 50 meters this way, 50 meters this way. And, the question is, from the starting point, what's his displacement, right? So he starts here, goes to the right, goes to the left, goes to the right, goes to the left. The question is, what's his displacement from the start, right? Yeah.
It'd be 24.
Well, yeah, well, it's not too hard, but you have to think about it for a second. Does anyone have an answer first? Yeah, 24. So the idea is, you just think about it, or you just sort of sketch it out in your head. So he goes 50 meters. It's kind of like the one that we did for the homework, right? It's the same thing, just going back and forth. So he goes 50 meters this way to get to the wall. 50 meters back gets him to his start. So basically, the distance is 100 meters. What would the displacement be? 0, right? And then he goes 150 meters to get to the wall again. And then he goes past that, because it's 176 meters, right? So how far past after the wall does he go? So it's 150 meters to get to the wall the second time, correct? So how much further does he go from the wall if it's 176 meters? He goes 26 more meters, right? 150 gets him to this wall for the second time, and then you subtract 176 from 150 gives you 26 meters, right? he's 26 meters from the wall. So he's here, right? And this is 176 minus 150, which is 26 meters. Sorry, I don't know if you can read that. 26 meters from the wall. But the question is not how far is he from the wall. The question is what is his displacement from the start of the race, which is this. Right? That's displacement, right? It's the length of the line that connects the start to the end. That's it, right? So it ends there, right? So what's the length of that line? What's the distance between the start? Yeah, it's just 24 meters, right? Because delta x, okay, it would be 50 minus 26. So it's technically plus 24, right? Because you're 24 meters to the right of where you started from, right? That would be the displacement for the entire race, correct? Does that make sense or no? Okay, so the last part is, yeah.
I didn't even do all the one.
Yeah, I mean, if you find it a different way, it's fine.
Yeah.
So what'd you do?
Just 200 minus 176. I don't know if that like is.
Yeah, you could do that because it's 200 to get to the back to the start.
Yeah.
And then if you subtract how far you are, that's how far you are from the start. Yeah, that's another way to do it too. Okay, so the next part is what's the average velocity at 80 seconds, right? The average velocity of the swimmer at 80 seconds, right? All right. Does anyone have an answer first before? What was it?
0.
0?
0.3. Velocity.
Yeah.
Average velocity is 0. Displacement is 0 over 80 seconds. 0 over 80.
No, it's not. At 80 seconds, he's 176 meters. He hasn't finished it. No. Okay, so everyone. Okay, so it's just. Okay, so the average velocity, right? What's the average velocity? It's the displacement at 80 seconds divided by the time it takes to travel that. So at 80 seconds, his displacement is 24 meters, correct?
Okay. That was a typo.
And then the time was 80 seconds, right? 'Cause he's, okay. So this is 80. So you get plus 0.3. Right? So that's his average velocity. So, I mean, if his distance was 200 meters, it's not, it's 176, right? What would his average velocity be? I already went over this in class, but one more time. If the distance that he traveled was 200 meters in a 200-meter race, what would his average velocity be? That would be 0, right? Because he's back to the same point he started from. So it would be 0, right? It would also be 0 at 100 meters, right? Because this is going back and forth. So at 100 meters, his average velocity would be 0 too, right? Because that's another time he's back at the starting point. All right. So does that make sense? Yeah?
Yeah.
Okay, so that was just distance and displacement, right? And average speed and average velocity, right? Without constant acceleration. But then you also have constant acceleration, of course, on the test, right? So does anyone have any questions with constant acceleration? Yeah.
Yes, I do. The problem I was given an initial velocity, a constant acceleration, and a total distance, and they wanted us to find final velocity, and I didn't know how to approach that.
For what problem?
I have it here if you want me to read it to you.
Where'd it come from, though?
It came from with the SI exam review handout.
Okay. So run it by me one more time. You were given.
I can read you the problem.
Okay.
An object is originally moving at 15 meters per second in the plus x direction. The object is under constant acceleration of 5 meters per second squared in the negative x direction with a total distance of 74 meters. What is the final velocity?
Okay, so probably means total displacement because distance is a little bit ambiguous. But so you use vf squared. You're asking for the final velocity, right?
Yeah.
So you need an equation with final velocity in it, right? You know initial velocity, correct? Well, all right, so you're given the acceleration, you're given the distance or displacement, right?
Yeah.
So,
In the equation.
yeah. So you want to have an equation with VF in it, VI in it, A in it, and delta X in it.
So the total distance in this case is the displacement,
I think so.
despite it going in two different directions. I guess. Start.
Yeah, okay, so you first have to figure out how far it goes till it stops, right?
No, it didn't ask how far it goes until it stops.
What was VI,
Yeah,
the initial velocity?
it was 15.
15? What was A?
5 meters per second squared.
15
That's
squared
in the
of
negative x. Actually, if it's in the negative x direction, it would be negative 5.
Mm-hmm. So, okay, so 15. Okay, so it goes 22.5 meters before it stops. I think that's what she means now. I just misinterpreted the question. So it goes 22.5 meters until it stops, right? Do you know how to figure out how far it goes before it stops?
Yeah, it didn't say it stopped. That's what.
But it will stop, right? So VI is in the positive x direction, correct?
Yeah.
A is in the negative x direction.
Uh-huh.
That means it's going to slow down and stop.
Okay.
So how would you figure out how far it goes before it stops?
So plug it into one of the formulas using the numbers you already have and just use, I guess, VF at 0 is going to stop.
Right, you use VF squared is equal to VI squared plus 2A delta X. And then you set VF to 0. So how far it goes before it stops is the velocity squared, the initial velocity squared, divided by twice the acceleration, negative twice the acceleration. So it's 22.5 meters. It's 15 squared divided by 10.
Yeah.
So it goes 22.5 meters to the right.
Mm-hmm.
Then it goes, stops, comes back to in the negative x direction.
Yeah.
So it goes 22.5 meters until it gets back to the point it started from,
Okay.
which is 45 meters.
Mm-hmm.
And then what was the distance? 70?
The total distance was 74.
74. Okay. So it's 45, what is it, 45 meters to get back to the starting point?
Yeah.
So then it's 74 minus 45.
Okay.
Whatever that is, 39?
29.
29, sorry. So the delta x is negative 29 because it's gone 29
Okay.
meters past.
And then plug it in the formula.
Then you use VF squared equal to VI squared plus 2A delta x. Delta x is minus 29. But then it's also negative because you're going in the negative direction.
Okay.
Yeah.
So for that same problem, just so I'm clear, so these are the ones that trip me up. So because it's gonna slow down and stop, we need to figure out, and we're eventually gonna use the okay, so because it moves in the positive x direction, slows down and stops, we have to find the displacement from that time in order to find the
Yeah.
I'm trying to wrap my mind around because these are the problems that.
Yeah. So when you're using the constant acceleration equations, right, all of them depend on displacement. Every one of them that has displacement. I mean, there's no distance in those equations, right?
Yeah.
It's all displacement. So if you know how far it travels in total, you have to figure out what that displacement is. And if v and a are in different directions, delta x and d are not the same thing. If v and a are in the same direction, then it is the same thing. It never changes direction, right? Anyhow, the point is, because v and a are in opposite directions, they're going to slow down and stop and then turn around. And the distance that it goes is generally just different than the displacement after some time. So that's why you have to do that. What other general questions do you guys have?
Can we do like another long one where we have to like use like an equation just to get one variable, and we have to do that you have to use that variable in another equation, and we have to use one equation to get a variable to get the second equation, and then you find the variable from the second equation. So until we need two variables, we need to use two equations interchangeably. It's like one of those long questions. I did those on the quiz. That was exactly what I did.
Okay. So, let's do one that's like sort of a derivative or something that's close to the one that I was just asked. So, all right. Okay, so an object is moving in the positive x direction at an initial velocity of 20 meters per second. Okay. So an acceleration all right, so it's constant. I forget the constant, but of course it's constant. Is applied to it such that it stops and changes direction. Okay, so the okay, so all right, so in a time of I'm just making this up. I don't know how it's going to work out. 10 seconds. All right, let's do this. Like I said, I don't know how it works out, but it's average velocity. This isn't that hard of a problem. I was trying to make a more complicated one on the fly, but it's tough to do. I have to really think about it. So this one's a little bit easier. All right. So you know in 10 seconds its average velocity is 0 meters per second. So the question is, what is the acceleration? No, what's the acceleration? I didn't give you the acceleration. All right, so try to figure that out. Does anyone have an answer? Yeah. Negative what?
40?
40? You're close. Yeah.
-4.
Yeah, it's -4. Okay, so what does it mean for the average velocity to be 0? It implies, right, because average velocity is displacement over time. So that means the displacement is 0, correct? So the displacement is 0, so you know the displacement is 0. So you know displacement. What else do we know?
Initial velocity.
Initial velocity. What else do we know? Time, right? So you need an equation with displacement in it, time in it, acceleration in it, and velocity in it. What equation is that? Does anyone know? Well, I don't remember the numbers, but does anyone remember what it? This one, right? So this is 0 for this particular problem because the displacement is 0 because the average velocity is 0. So then you just solve for A. So let's just solve this for A. So there's different ways of doing this, but you got to subtract something from one of the. I'll do it like this. So you subtract maybe VIT from both sides. And then what happens to one of the t's? VIT is equal to 1/2 AT squared. So what happens to one of the t's cancels? As long as the t isn't 0, you can do that. It's not 0, it's 10 seconds, right? So you have negative VI is 1/2 AT, correct? So then you have to solve for A. So it's A. Well, you have to multiply by 2 to get rid of the 1/2, and you have to divide by t. Yeah. It algebraically cancels out, right? Just algebra. So it's -10. This is +10. And this is, wait, it's 20, right? Sorry, 20. I was like, oh, why is that not working out? This is 20. Okay, then you divide that by 10. The time was 10, right? So you can just do this in your head. You don't even need it. It's just -2 times 2, right? Which is -4.
Where did you get -2 from?
Hold on. 1 second. So it's in the negative x direction. So if I just ask for the acceleration, it's technically 4 meters per second squared in the negative x direction. Okay, so what's the question? Where did I get the 2 from?
And yeah, the -2.
Just algebra. So.
I followed, I got -VI equals 1/2 AT, and then you lost it.
Well, you got to solve for A, right?
Uh-huh.
So how do you solve for A?
You divide by 1/2 of AT.
Okay, or the other way of saying that is you multiply by 2.
Oh, and you just, okay, with the negative you put it, okay, I got you.
Okay. Okay, so that's the acceleration. Yeah.
Okay, so just to be clear, the displacement is 0 because since the average velocity is displacement over time, it's 0.
Mm-hmm. So average velocity is 0 is synonymous with displacement being equal to 0, right? That's another way to think about it. Okay, so let's ask this. So this is kind of related to that problem. Now I can ask something related to this. What is the average speed at 15 seconds? So at 10 seconds, the average velocity is 0. What does that mean? I mean, it means it came back to the same point it started with, right? So the question is at 15 seconds, not at 10 seconds, at 15 seconds, assuming the acceleration is the same, it doesn't change. What is the average speed? So try to figure that out. Anyone have an answer? What's that? 54? Okay. Any other answer?
20.
Okay. Any other answer? Yeah.
23.3.
Okay. Oh, wait. Sorry, I forget to do this. I forget one thing. Yes, that's right. Yeah. Okay, so so this is kind of like the question that was asked. You have to figure out its displacement. Well, there's different ways of doing this. There's actually quite a few ways, right? But what's average speed? Let's start with that, right? How do you figure out average speed first? Right. So we need to figure out how far it's gone in 15 seconds, right? So it's stopping and changing directions. So we have to figure out, it's kind of like the homework in a sense. We have to figure out how far it goes until it stops first. There's different ways of doing it. This is one way, right? So how do we figure out how far it goes before it stops? There's also different ways of answering this. But what's one way? Does anyone know one way of figuring out how far it goes before it stops? Using a constant acceleration equation?
After the VF equals VI plus
You can use that,
VF squared equals
but
VI squared
yeah,
plus 2.
this is the better one because you don't know how long it takes. Although if you think about it, you could probably guess how long it takes to stop. But what is VF? 0 because it stops, and you're going to use A from part A, so you have to make sure A is right, or else you're going to get this wrong. But assuming A is correct in part A, we can use that here because it doesn't change over the course of the entire problem, and you use this to find delta x. So we're going to solve this equation for delta x. So what you do is you subtract maybe 2a delta x from both sides, and then how do you find delta x? It's VI squared over 2a. So VI was 20, right? Am I getting that right? Okay, 20 and then divided by 2. It's negative 2a, sorry. Negative 2a because there's a negative there. So it's negative 2. And a was negative 4. So this works out to be 100 meters. Positive. So let's think of what's going on. I'm just going to hand sketch it here. I can draw my x's, but it's just easier to hand sketch it. So it starts here, and then it goes 100 meters here before it stops, right? So this is 100 meters. Right? That's what it means, right? Until it stops, it goes 100 meters. So in 10 seconds, where is it? From part A, or the given information, right? At 10 seconds, where is it?
20 squared divided by 8 is 50 meters.
What was that?
20 squared divided by 8 is 50 meters. Right?
Oh, yeah, sorry. I was doing an extra step when I did it. Yeah, that's right. 50 meters, my bad. Okay, so 50 meters. I was doing this step here. Okay. So the question is, at 10 seconds, where is it? From the given information and what you did in part A. So at 10 seconds, where is it? Yeah, it's at the start. So how far does it go in 10 seconds? 100 meters. That's where the 100 came from because I was doubling it. So it's 50 meters this way and then 50 meters back. So at 10 seconds it's here, right? So the total distance it's gone is 100 meters to that point, correct? 10 seconds. But at 50 seconds, is it here or, it keeps on going, right? So it's over here somewhere in 15 seconds. So you got to figure out how far past the starting point it goes, right? Does everyone see? It goes 50 meters this way. Stops, goes 50 meters back, and then the displacement is 0, right? And that's after 10 seconds because that was given in the first part of the problem. So how do we figure out how far, where it is at 15 seconds, right? because you have to figure out how far past the starting point it goes to get the total distance, right? It's 100 meters for 10 seconds, but we need to figure out what the distance is for 15 seconds. So does anyone have any idea how to do that? There's, okay, so there's more than one way of doing it. One way of doing it is using the extra 5 seconds. In other words, you know at 10 seconds it's here, right? So the question is how much further does it go in 5 seconds? That's one way of doing it. The other way of doing it is using the entire time of 15 seconds. In other words, if you put 15 seconds into the constant acceleration equation, it'll tell you your displacement from the start automatically. It knows that it's stopping and turning around. So suppose you know the time is 15 seconds, correct? How would you figure out the displacement? Just forget about this part. The question is, what's the displacement after 15 seconds? Or at 15 seconds? How would you figure that out?
You just plug it into the
First
equation.
ingredient?
Yeah, you use the equation we used before, except we're trying to find delta x this time.
Yeah.
And it's the same thing. So in other words, if you put in 20 meters per second plus 20, 15 seconds, plus 1/2, minus 4 from part A, and then 15 seconds here, this works out to be a delta x of minus, wait, is that right? Yeah, it is. Okay, so, never mind. Okay, so it's minus 150. So what does that mean? It means that 15 seconds is 150 meters to the left of where it started. That's what that means, right? So you put all this picture together. I'm going to move this over a little bit. It's not to scale because I can't draw this whole thing here to scale. It's going to run out. I'm going to run out of room. But it tells you that at 15 seconds, it tells you exactly what the displacement is. It's 150 meters, negative 150. So that means that, you know, after 50 seconds, you end over here, right? You're 150 meters to the left of where you start. So what's the total distance that you travel? So yeah, I corrected this, but actually I was right the first time. Yeah, it's 250 meters, right? If 50 meters till you stop, 50 meters till you come back, it's 100 meters. And then at 15 seconds, you're over here. So the total distance is another 150 meters past that point, right? So what's the total distance again? 250 meters, correct? 50 meters gives you 100 meters, and then another 150 meters. Right? Does everyone see that? It's 2 times 50, because it's forward and back, plus this extra 150 meters. So it's 250. Does anyone know how you do it with the 5 seconds? In other words, we know where it is at 10 seconds, right? It's back to the start. So the question is, you know, how much further does it go in the last 5 seconds, right? Like if you knew where it is at 10 seconds, how can you figure out where it is at 5 more seconds after 10 seconds, which is 15 seconds? Does anyone know how to do it with the 5 seconds instead of the 15 seconds? There's another way to do
The
it.
displacement at 10 seconds is 0, so you just, that's really 100, so you just take 100 minus 250 prior to what you did.
So at 10 seconds, we know the displacement is 0. That's correct. What'd you say after that?
So that means the total distance would be 100 at 10 seconds.
That's correct.
So you just take the total that you just found and subtract 100. And that value would be what you found within the last 5 seconds.
Right, but I'm saying, how do you get this delta x is minus 150 using the 5 seconds?
Oh,
Okay. So it's the same equation, right? As this that we just used, but there's a difference here because when it gets back to the start, what's its velocity here at this point? At 10 seconds, what's its velocity? Does anyone know? We went over it at some point. It's not 0. So what do we know? We know that VF squared is equal to VI squared plus 2A delta X, right? This is one of the equations. What's delta X at 10 seconds? No, 10 seconds. 10 seconds. What's the delta X at 10 seconds? 0. So what is VF in terms of VI?
VF is 0, the velocity.
No. So you have VF squared is equal to VI squared. So what is VF in terms of?
VF squared equals VI squared plus 2A. Oh, no.
It goes away. You have VF squared is equal to VI squared. So what is VF?
VF equals VI. 20 meters per second.
Almost. Plus or minus VI? Is it plus or minus?
Minus, going past to the negative direction.
So that answers your question. When it gets back to delta X is 0, it's not stopped. It's going in the opposite direction at the same velocity, correct?
I'm sorry?
Your question before is why can't you use VF is equal to VI plus AT for the first part?
Yeah.
You said VF was 0. It's not 0. It's minus VI when it comes back to the start.
Yeah.
Okay. So you can use this. Okay, so basically what I'm saying is if you want to use the 5 seconds, right, this is how you would do it. You know that at 10 seconds, it's back to its starting point, and its velocity at 10 seconds is what? We just figured it out, right? What would the velocity at 10 seconds be? Negative VI, so it'd be going negative 20 meters per second, right? So that point, when it gets back to the start, is going at negative 20 meters per second, correct? So this would be, I don't know why it's not changing. That would be minus 20, because the initial velocity at 10 seconds would be negative 20. This would be 5, because you're saying, how far does it go after 10 seconds, right? So it's 10 to 15, which would be 5 seconds. And this would be 5. What does that give you if you change it to that? Anyone see? Negative 100, right? 20 times 5. What's 5 squared times 2? What's 5 squared? 25. What times 2? 50. But there's a negative there. So it's negative 100 minus 50 gives you what? Negative 100 minus 50, or 100 plus 50. Negative 150. So you get the same answer, right? In other words, from 10 seconds to 15 seconds, the displacement is minus 150. It's the same answer either way is what I'm trying to say, right? Either way, you get the same answer. There's 2 different ways of looking at the same thing. Okay, but the point is the total distance is 250, right? It's 150 plus 100. Plus 2, yeah, 150 plus 100. So what's the average speed?
16.67.
Yeah. Mm-hmm.
So if I wanted VF to equal 0, though, I'd have to apply positive acceleration during the second half, hypothetically, right?
Yeah, you need to change the value of the acceleration, right?
Yep. Thank you.
Yep. 15, right? Because it's the total time. So this is what, 16.67? That was a little bit hard, but you get the idea, right?
We're gonna do one tomorrow, like this.
What?
Is there gonna be one like this tomorrow?
I don't know.
Yes.
So basically, there's no, like, for average speed is equal d over delta t, so there's no real, like, equation that you can, like, solve for d. So you just have to, like, visualize it and, like, add 2 things together to find d. That's the
Right.
way you can target it.
Any other questions or anything?
We're lost. Let me try and go through it. Come on.
Okay. Are there any more questions? You guys have more questions?
So,
If you mean where did the negative come from? Is that what you're asking?
No, the VF equal negative.
It's just the equation, right? If delta x is equal to 0.
Right there, yeah.
So
So delta x is 0, right?
delta x is 0, right?
Yeah. And how about it 2a?
Well, it's multiplied by delta x, right? So the whole thing goes away. Okay? Yeah.
do you know how the quiz you said you were gonna use credit because of those free questions? When is that coming to?
That's a good question. Didn't go over that yet. Oh, it's when I post your quiz average, right? So basically, in my grade book, not on campus, in my grade book, I'm gonna add 30 whatever points it is to everyone, and then when I calculate your quiz average and post it on Canvas after the first test, it'll be there.
And typically, how long does it take to grade the tests since we have to do all that?
It's going to be a while. There are a lot of students in this class, more than I've ever had, but probably sometime next week. There's a whole PowerPoint on everything that's on the test. Yeah. Okay. I assume no one has any more questions since everyone's leaving. So I'll post this in a bit, in like an hour or two.